All right, guys, so lots of us are still struggling with solving, so I made this extra video to hopefully help a few of you out. Lots of us keep forgetting our rules of exponents as well as some rules of logs, so I'm going to give you those that we are struggling on, and please make sure that you're taking the time to memorize those. So one rule of exponents is going to be when we are multiplying exponents. So if we were to have the same base of a, and they both had exponents, okay, we add together the exponents. So this would be a to the x plus y, okay. The other one is division. So again, we have to have that same base, but with division, we would subtract the powers. So this would be a x minus y. Okay. The other rules that we can't tend to forget are those of negative powers as well as powers that are fractions. So negative powers will flip what we have. So what we mean by that, so again with my examples of using a, if we have a to the negative first, okay, that's going to be 1 over a, okay, or if it had started as 1 over a, and we put that to the negative first, that would just equal a. Okay, so negative powers tend to create fractions or take the fraction away, but it does not always have to be a fraction, right? For the second example there, it was not a fraction. Then we have our fraction powers. And those actually will equal our radicals. Okay, so if we were to have the square root of a, that's actually equal to a to the 1/2. Or if we were to have the cubed root of a, that would equal a to the 1/3. Okay, so those are things that we need to make sure we're keeping in mind and would be extremely helpful for our test. Now the rules of logs, okay, we did talk about those rules and you have class notes on those, but we are forgetting them at times. So if we have logs, with the same base that are added together, okay, we actually will multiply them. Okay, so if we see addition, we have to multiply first. We have to condense that back. Okay, if you see a minus, in the middle, that is division. So the log base stays the same and we would divide x over y. And the last one is the power property. Normally we will want to be bringing the powers back up. Actually, we'll want to bring them to the front, and depending on what's going to help us, we need to know which way we need to go. So we might need to bring it back to the power or bring it back out in front. So you might originally see it as x of log base b of y, and we would bring that x back to the front, back to the power, so log base b of y to the x. So sometimes that might be helpful to us. So in cases that is helpful, it's when the base equals the y there. So if it had said log base y, of y to the x, we would want to bring that power back up. Now, if we had just a number on the other side and we were seeing, well, we would need to use the inverse, then we would want the power out in front so we could divide by that number. So those are things to make sure you're looking out for. All right, so now let's look at a few examples. Okay, so I'm looking at some exponent examples here, and these are going to be one-to-one. And I noticed that they're going to be one-to-one because I'm looking at these and I'm looking at what are the bases of my problems. So here in example 1, I have 216 and I have 1/6. I know that 6 to the third power is 216. Now, if I have 1/6 and I want 1/6 to be my base, it means that I have flipped my 6 down. So that means the power that I'm going to choose is negative. Okay, and again, I know that 216 is to the third power, so it's going to be negative 3 times my 3x minus 2 there on the powers. And the 1/6 over on the right side is going to stay the same. Okay. And I'm going to multiply my negative 3 back in there, as well as drop my bases, because again, this is one-to-one. Once the bases are the same, I can cancel them out. So I'm going to have negative 9x minus, well, it's a negative times negative, so it'll be plus 6 equals 2 minus x. And now from here, I'm just solving like a regular equation. So I would move my 9 to the other side to get myself an 8x, and I would subtract my 2 to the left side to get 4. And then I would divide both sides by 8, so x would equal 1/2. Okay. Again, I think the hardest part for you guys is finding what your base will be. I tend to choose my smallest number that is up there. If there is not a number that's small up there, I go down to my lower numbers and try to see if those, I can find like 2 or 3 to the power of something that goes into that number. So example number 2, this time we've got some multiplication happening. So we're going to have to use even more of our exponent properties. And over here I'm seeing that 2 on the right hand side is probably my lowest base. So I'm going to try to change everything to a 2. 16 is 2 to the 4th power. So I'm going to rewrite that as 2 to the 4th, and I'm going to multiply it by x plus 2 up there in the exponent. And I'm still multiplying by 2 to some power is 32, 2 to the 5th power. Okay, and then I'm going to multiply that by 3x. And the 2 to the x over on the right will just stay the same. Okay, I'm going to multiply through so that I have a simple exponent in the top. So I have 2 to the 4x plus 8 times 2 to the 15x equals 2 to the x. Okay, now I'm multiplying exponents. Again, back to that rule over here, when we multiply exponents, right, we're actually adding their powers. So we're going to add together their powers to get 2 to the 19x plus 8, because 4x plus 15 is 19, equals 2x. Now that we have the same base and we're down to one single term on both sides, we can cross off the bases of 2, and we get 19x plus 8 equals x. And we're going to subtract the 19x to the other side, so 8 equals negative 18x, or x equals 8 divided by 18. Got a negative there, and I would simplify that, right? They can both be simplified by 2, so negative 4 over 9 would be my final answer there. Okay, again, I have about 8 examples here. If there's a certain type that you are struggling on, just fast forward the video to find that type of example. So our third example here is still exponents, but I'm noticing now that I don't have exponents on the other side. So I'm now going to have to use that inverse property. And I have noticed that lots of us are getting confused about the inverse property, so please make sure you're paying close attention. So we have to subtract the 10 first because we need to isolate our exponential in order to take the inverse of it. So we're going to have 9 to the negative 2x equals 13. Okay, now we have gotten the exponential by itself, and we're going to take the inverse of the exponential, which is the log. And I'm going to use exactly the same base that I had for my exponential. And the base of the exponential is the 9. So I'm going to write log base 9 and log base 9 on both sides. And now I'm going to take those values that I had in blue, and I'm just going to write them right next to my logs. There's a 13 over there. Okay, now on the left side, the inverses will cancel each other out. So the log base 9 and the 9 of the exponential will cancel each other out, and we're left with what is in the power there, which is negative 2x. On the right, we cannot cancel because 13 is not the same base as 9, so we're just going to have log base 9 of 13. Be careful, the 13 is not an exponential of the log, okay? It is just log base 9 of 13, so they should be written on the same line. And then lastly, we're going to divide by that negative 2. So our answer would be log base 9 of 13 divided by negative 2. Okay, this one is slightly different just because we don't have a number now as our log. We have e, right? Still need to isolate it so it's by itself. So I'm going to add the 4 to the other side, and I'm going to get e to the x minus 9 equals 58. Okay, now I got to get rid of e. So the inverse of e is the natural log, which is ln. So I'm going to write ln on both sides. And then I'm going to take that green and I'm going to put it right there next to my ln's. Again, they are not to the power of 2. So now the ln and the e cancel. We're left with x minus 9 equals ln of 58. Okay, and now I need to move my 9 to the other side. So I'm going to have x equals ln of parentheses 58 my plus 9, because we have to move the minus 9 over. Notice that I put the 58 in parentheses because the 58 is attached to the ln. The addition of the 9 is not. We do that after we have operated the ln of 58. Okay, so now we're going to go from logs being our answer. The other examples were with exponentials. These are now with logs. So I'm noticing that both of these logs here in example 5 are the same. So I can actually just cancel them out. It's the great part of the one-to-one property with logs. They just say goodbye. So we have 3x minus 9 equals 2x. We're going to move the 3x over to the right. So we get negative 9 equals negative x, or x equals 9. Okay, example 6, now we've added some operations. I actually see that I had a typo there. This should just be base of 19. Okay, so I'm noticing that all of the bases are the same. So I'm like, okay, I need to get down to 1-to-1. But I need to have a log base 19 equaling a log base 19. So I'm going to have to combine my terms here on the left side. And there is a plus, and we're going to use our log property of addition, which tells us we're now multiplying. So we're going to have log base 19 of x times 3x plus 2 equals log base 19 of 35 plus 2x squared. Okay, I'm going to multiply this out, so I'm going to get log base 19 of 3x squared plus 2x, which equals log base 19 of 35 plus 2x squared. Okay, now the bases are the same. I only have one term on the left. I only have one term on the right. So I'm going to cancel out my logs. Okay, so I have 3x squared plus 2x equals 35 plus 2x squared. Okay, I'm seeing squareds, I'm seeing x's, and I'm seeing a number. That means I'm going to have to factor. So factoring is very important. If you're still struggling with factoring, please make sure you sign up for Bear Block. Okay, we're going to move everything to one side in order to solve a quadratic. So I'm going to move my 2x to the right, and I'm going to move my 2x from the right to the left. So I'm going to get x squared plus 2x minus 35 equals 0. Okay, so I'm looking for factors of 35 that add to 2. So, and they have to be a difference because one is a negative and over here is a positive. So I'm going to have x plus 7, x minus 5. So 7 times the 5 would give me that 35, okay? And then you add them together and you would get the 2x equals 0. And then I would set each of those pieces equal to 0, so x would equal negative 7, and x would equal positive 5. My last step, because I got a negative, is to double check that I am allowed to have a negative. So I'm going to take that negative 7, I'm going to come back up here, and I'm going to put it in here and see if it does anything that I don't want it to do. And it does. If I were to plug it into this piece here, we would get an error. I don't know why I put negative 17. My bad. We would get an error because we can't take a negative log. Okay? It's not in its domain. So negative 7 would be out, and our only answer there would be 5. Okay, let's check out the last two examples here. Okay, I'm noticing that I do not have logs on both sides, so that means I have to use the inverse property. Okay, so for number 7 over here, we have ln x minus 5 equals 6. So the base of ln is e. So I'm going to exponentiate both sides with the letter e. So I'm going to write e on both sides, and then I'm going to fill in the pieces that I had above. Those become the exponent of my base. So it's going to be ln of x minus 5 equals e to the 6th. Okay? And now that ln and the e are canceling, and we're left with x minus 5 on the left. Actually, that, yeah, equals e to the 6th. And now I'm adding my 5 to the other side. So x equals e to the 6th plus 5. And that would be our answer. Okay, some of us were exponentiating one side but forgetting to do the other. Remember, if you do anything to an equation, you have to always do it to the other side as well. Number 8 is now using some of our properties. We have a minus there. Remember, minus is division. So I'm going to have log base 3 of x squared divided by x equals 3. And I know sometimes division to us is scary, but this division is actually pretty easy because x squared divided by x is just x. So we're going to have log base 3 of x equals 3. Now we have to get rid of the log to solve for x. So we're going to choose the base of the log, which in this case is 3. Okay, so I'm going to exponentiate both sides with a 3, and then I'm going to take both of my pieces and put them in the powers. So I'm going to have log base 3 of x equals 3 to the 3rd. And these will cancel on the left there to just leave us x. And we will have 3 to the 3rd, which is 27. And that is our solution. So if you have any more questions, please feel free to bring them in to class and keep up the hard work.